I think the answer is yes, yes, and yes. A bit of everything, right? So if you just start at the simplest level and say, we have 350 robot employees spread around the world, the software has to tell them what to do. So we would call that command and control at the simplest level, right? How do they know what to do, when to do it, et cetera? And then once they're doing whatever it is they do, in this case, taking pictures of the night sky, those images have to be processed. So there's a whole processing chain for turning pictures into measurements. And then once they become measurements, that's really when the fun starts, right? You turn those measurements into orbits, you turn all the orbits into a catalog. From there, you can look at changes in behavior. You can start to roll that catalog forward in time and see if there are any risks. And we just try to keep it simple. So like the whole sort of, if you were just to wrap up in one idea, the suite of tools, if you don't measure it, you can't manage it. So we have a lot of our software stack is really to make sure we can take as many really accurate measurements as possible. And then the next bit is, if you can't predict it, then you don't understand it. And so we have an entire software stack that is designed to help us predict or roll that information forward, because that's where the decision-making comes in for our operators. And, prediction is hard, especially about the future. So we spend a lot of time working on those tools and making sure that we really understand current state, what happened in the past. Can we take those two things together, roll it forward, and figure out, based on understanding what's the most likely course of events going forward, is there any risk that we see based on sort of nominal? And then if we see any changes from what we would expect, can we update our customers about that so they can take some action?
Okay. Clint, this question just struck me then as I'm hearing more and more about what you do. How would you contrast what you do with the Leo Labs?
So we typically focus on higher altitudes, so 8,000 kilometers and above. So that's MEO. I think that's where, so the things that are about 8,000 kilometers, I think in that area is something called O3B. If you've heard of that satellite constellation, sort of the next class of satellites above that are all the global positioning system satellites, or all the GNSS satellites. So GPS, Galileo, GLONASS, et cetera. And then you get above that, and then you're into geosynchronous, where all of mostly all the communication satellites, weather satellites are at up there. We tend to focus on that part of on those orbits, those higher altitudes. That is our sweet spot, and that's where we focus. Leo Labs, with their radars, is focusing on low Earth orbit, things that are closer to the Earth. And I think they kind of focus from the ground to about 2,000 kilometers is kind of the area that they focus on. We don't typically do Leo. We can on demand. In general, as a course of sort of day-to-day operations, we don't. From a technology perspective, nothing prevents us from doing that. That's really just a business decision today. We have found more value for us, and we're a small business, so we can only go see who we can see. To date, we found geo to be a better market for us, so we haven't made that transition. And they're doing a good job, right? So they do a good job in their area. We're doing a good job in our area. So right now there's no incentive for us to try to go and do anything down there. It's interesting what's happening in Leo. But that tends to be where they focus, and we tend to focus higher.
Okay, very cool. So niche down, and with Leo, it's in the name. So okay,
you get your head concept right.
Right. I'm curious if there is anything missing. You've had this experience now. You've been with the company for like 7 to 8 years now. It's been a long time. Is there anything in the ground stations or the sensor equipment that you wish existed that you don't have? Or is everything great?
Actually, in terms of hardware, there are other industries driving the hardware for our business. And so telescope manufacturing is really good. In fact, if you were to go to Italy, if we could steal Galileo's telescope and connect a camera to it, it would work just fine. And it's hundreds of years old. But modern telescopes are, they're manufactured well. They hold up to weather well. So from a hardware perspective, they do well. The camera technology is really being driven by other industries, right? Sony, Canon, they are just, printing gobs and gobs and gobs of cameras. So we can just exploit the advances that they're making from their R&D budgets. And then compute technology, again, other industries are driving the need for fast, stable compute, and we're just exploiting that. And what we do is we write custom-built software that enables modern, well-built telescopes with modern, well-built cameras with modern, high-end compute to do amazing things. So we're sort of taking advantage of all the gains that other industries are pouring into the technology that's required to do what we do. But then our expertise is software. So, we are the best in the world at focal plane processing, the exploitation of those pictures, fast, accurate, sensitive. But again, that's been our life's work for a long time.
More engineers are not going to solve your problem. It's not a technical problem in that sense. It's a process problem. And the time to fix your processes was 20 months ago. And the second best time is today. This is Jason Kanigan, the president of Cold Star Technologies and the host of this podcast, the Cold Star Project, which is all about identifying and solving process problems for space companies, because that's what we do. And you can hear the entirety of this episode by following the link in the comment below.